Good morning, everyone. Welcome to another math exciting episode here in Valenzuela Live Mathematics 6. Once again, I am Mrs. Juanita F. Maquinto of Lawang Bato Elementary School, your FB live streaming teacher for today. Before we proceed, I want you to type in your complete name, grade and section, subject teacher, and school in the comment box, so that your teacher would recognize your attendance and participation. Then use the comment box to type in your answers to the questions that I will be giving during the discussion, and make sure you have your self-learning module, pen and notebook to take down notes. Now, we are on the 8th week of the 4th quarter as we continue in our live streaming session. Our objective is based on the most essential learning competencies. At the end of this session, you are expected to make simple predictions or events based on the result of experiments and solve routine and non-routine problems involving experimental and theoretical probability. For the first activity, you are going to read, analyze, and solve for the number of possible outcomes of each event using listing or tree diagram. Choose the letter of your answer. You are given 30 seconds to answer each problem. Number 1, Alan rolls 2 dice with different colors on each face: red, blue, orange, pink, green, and yellow. How many color combinations will show up? It's letter D, 36. Number 2, Sarah has 3 pairs of sneakers, white, blue, and gray, and 5 pairs of socks with different colors. How many ways can she wear her sneakers? It's letter C, 15. Next number, 2 spinners span as shown in the figure below. How many possible outcomes will occur? The correct answer is letter D, 18. Number 4, there are 4 number cards as shown below. How many different 2-digit numbers can we form? The correct answer is letter B, 12. Last number, 5. Risa has 6 blouses and 4 skirts. She wants to find out how many outfits can she make with these clothes. The correct answer is letter D. Did you get all the correct answers? Great! In your previous lesson, you have learned how to make listing and diagram of favorable outcomes and chances. Before we start with our discussion, let us define first some words that we may encounter along the way as we talk about in our topic. Probability. It is a measure of estimation of how likely an event will occur. For example, when tossing a coin, the probability of getting a tail is 1/2 or 50%. Since a coin has 2 faces, and when it is tossed, we might get either a head or a tail. The probability of an event is expressed between the range of numbers from 0 to 1, where roughly speaking, 0 indicates impossibility of the event and 1 indicates certainty. The next one, we have theoretical probability. It is the number of ways the event can occur or what we expect to happen. It is required to conduct an experiment. The next one, we have experimental probability. It is based on the results of an experiment. For better understanding of our lesson, let us study this problem. Marlon has marbles in a box. There are 4 red, 2 blue, 3 green, and 1 violet. What is the probability of getting each color out of the box? Since there are 10 marbles in a box, the chance of getting red marbles is 4/10 or 2/5, 4 out of 10 or 40%. How about the blue marbles? What is the probability? Correct. The probability of getting blue marbles is 2/10 or 1/5, which is 2 out of 10 or equal to 20%. Next, count the green marbles. How many are there in the box? Yes, there are 3 green marbles. It is 3 out of 10, 3/10 or 30%. How about the violet marbles? What is the probability of getting violet marbles? Yes, it is 1/10 or 10%. The probability can be written in fraction, decimal, or percent. When it is written in fraction, it is always expressed in lowest term. In this activity, we only identify the number of ways the event can occur or the favorable outcomes out of the number of total outcomes that is called theoretical probability. In finding theoretical probability, we may use this formula as probability of an event is equal to number of favorable outcomes over number of possible outcomes. Another approach used in finding the probability of an event is through conducting or doing an experiment, which is called experimental probability. Here are the steps to follow. First, take a marble inside the box. Next, record the color and return the marble in the box. Then repeat the process at least 10 times. Lastly, count the number of times each marble picked. Now, let us perform this activity. The first marble picked is red. Then make a tally mark which is red color. Second is green. Then mark color green. Third marble is blue. Then mark blue. Fourth marble is red. Mark red. Fifth marble is blue. Mark blue. Next, red marble, mark red. Another one, green marble, mark green. Next, violet marble, mark violet. Then, red marble, mark red. Last, pick green, mark green. Based on our simple experiment, the table shows that red marbles appeared 4 times. So, the experimental probability will be 4/10 or 2/5 or 40%. The blue marbles appeared 2 times. 2 out of 10. The experimental probability is 2/10, 1/5 or 20%. The green marbles appeared 3 times. 3 out of 10, 3/10 or 30%. And the violet marble, the experimental probability is 1/10 or 10%. The formula in finding the probability of an event is equal to the number of times an event occurs over the number of times the experiment conducted. After recording the number of times the marbles appeared, compare the results of theoretical probability from the experimental probability. What do you notice? Precisely, there is difference. Why? Simply because in theoretical probability, the outcomes are based on what we actually expect to happen, whereas in experimental probability, it is based on the result of the experiment and the result may vary. As more trials conducted, the experimental probability generally gets closer to the theoretical probability. Let's have another problem. A spinner is divided into 8 equal sections numbered 1 to 8. Make predictions based on the problem. Just keep in mind that in finding the theoretical probability, we can use this formula. Probability of event is equal to number of favorable outcomes over number of possible outcomes. What is the probability that a spinner will stop on number 5? Correct, it is 1/8. Since in the spinner, there is only one number, numbered 5. Therefore, there is only one favorable outcome over the total number of possible outcomes. Next, what is the probability of getting prime numbers? What are prime numbers? Prime numbers are whole numbers that are greater than 1 and have only 2 factors, 1 and itself. We need to identify first the prime numbers between 1 to 8. They are 2, 3, 5, and 7. Therefore, there are 4 favorable outcomes out of 10 possible outcomes. The probability of getting prime numbers is 4/8. Plus, what is the probability that the spinner will stop on numbers divisible by 3? We need to identify the numbers that are divisible by 3. What are these numbers? Yes, they are 3 and 6. How many favorable outcomes? Correct, it's 2. The probability that a spinner will be landed on prime numbers is 2/8, or 1/4, which is also equal to 25%. How about if the spinner spun for 30 times? Find the experimental probability for each number in the spinner. Here are the results of the span. Number 1 on the spinner appeared 3 times. The number of times over the total number of trials is 3/30, 1/10 or 10%. 2 appeared 4 times. The experimental probability will be 4/30, 2/15, or 13 3/33%. Number 3 on spinner appeared 2 times. It is 2/30, 1/15, or 6 67%. Next, number 4 appeared 5 times. The experimental probability is 5/30, 1/6, or 16 67%. How about number 5? The spinner stopped 6 times. It is 6 over 30, 1/5, or 20%. Let's have number 6. It appeared 4 times. The experimental probability is 4 over 30, 2 over 15, or 13 and 33/100%. Number 7 appeared once. Probability is 1 over 30, or 3 and 33/100%. And number 8, it appeared 5 times. The probability is 5 over 30, 1/6, or 16 and 67/100%. For better understanding, we have another problem. 2 coins are tossed at the same time for 20 times. Below are the result of the tossing of coins. Row 1, head and head, head and head, head and tail, head and tail, head and head. Row 2, head and tail, head and head, tail and tail, tail and head, head and tail. Row 3, tail and tail, tail and tail, head and head, head and tail, head and tail. Row 4, head and tail, head and head, tail and tail, tail and head, tail and head. Based on the data above, answer the following questions. What is the experimental probability that the result is a head and head? There are 6 out of 20. The probability is 6 over 20, or 3/10. How about number 2? What is the experimental probability that the result is tail and tail? Yes, it is 4 over 20, or 1/5. Number 3, what is the experimental probability that head and tail, or tail and head, and vice versa appeared? Head and tail appeared 7 times, and tail and head appeared 3 times. So, the experimental probability is 10 over 20, or 1/2. Now, it's your turn to explore. Directions: read, analyze, and solve for the probability. For number 1, determine the theoretical probability of the event rolling a multiple of 3 from a cube. The correct answer is letter B, 1/3. Number 2, what is the probability of drawing a king from a deck of 52 cards without replacement? The correct answer is letter C, 4 over 52. For number 3, a number is chosen at random from 1 to 10. What is the probability of selecting a multiple of 3? It's letter D, 3/10. For number 4, an experiment consists of rolling a pair of dice. Find the theoretical probability of getting an 8. It's letter A, 0. Number 5, the letters from the word mathematics are placed in a box. What is the probability that you will select letter M without looking at the box? It's letter B, 2/11. To sum up our lesson for today, we should remember that when dealing with probability, we can use two approaches: the theoretical probability and the experimental probability. The theoretical probability, it is the number of ways the event can occur or what we expect to happen. It is also the ratio of number of favorable outcomes over the number of possible outcomes. This is of the results of an experiment repeated many times. Now, it's time for our question and answer. If you have questions, just type it in the comment section. I will do my best to answer those questions. Here, we have a question. What is the difference between the theoretical probability from experimental probability? The difference of the two is in theoretical probability, we attempt to predict what will occur without actually performing the experiments, while in experimental probability, the probability of an event is based on what has actually happened by conducting of actual experiments. If there's no more question, I want you to get your self-learning module and take note of your assignment. For your assignment, answer the assessment on your self-learning module. Your discussion teacher will be the one to check it. Before I end this session, I would like to share with you a quote that says, "The most important thing in life is to stop saying, 'I wish,' and start saying, 'I will.' Consider nothing is impossible. Then, treat possibilities as probabilities." By Charles Dickens. And with that, thank you so much, grade 6 learners, for actively participating in our Valenzuela Live streaming session for this school year. Keep safe, everyone. Goodbye, learners, and God bless.